Hello and welcome to the first part in my Proofs Explains series. In this video we're going to start with proof by deduction. Proofs are incredibly important as part of mathematics and also physics. So the first thing we should go through is what is proof by deduction, and more fundamentally what is deduction. Well, deduction, if you're mathematically defining it, is to prove something by using logic and mathematical principles. So in simpler terms, when you deduce something, use existing facts or statements to draw conclusions and create further facts. So let's take an example using this dog. What do we know? Well, in the background we can see there is a puddle. Right, that's one fact that we know. The other fact that we can see from this picture is that the dog is wet. And the last fact is that there are no other sources of water. So no other sources of water. So what I mean by that is it's not raining, right? So what can we deduce from this? So what conclusions can we draw? Well, the deduction that we can make is that the dog got wet by jumping into the puddle, or more fundamentally that the dog jumped into the puddle. Okay, so even though this picture doesn't show that the dog actually jumped into the puddle or ran through it, we can deduce that it did jump into the puddle or ran through it, because there is a puddle in the background, the dog is wet, and it's not currently raining, and there's no other way it could have gotten wet. So this is one example of deductions. Another way to look at it is when detectives take evidence and draw conclusions as to who committed a crime. So for example, Sherlock Holmes, they use deduction. So they take a series of facts and draw conclusions from those facts. So just before we get started, with proofs there are a lot of different tricks that we can use in order to make our life easier. So for example, this one down here is that even numbers can be written as 2n. So if you wanted a generic even number, you just write 2n, where n is an integer. There are many tricks like this. So instead of listing them all out at the beginning, what I'm going to do is I'm going to take a variety of examples over the next few videos, and I'll introduce the tricks to you as and when we need them. That way you can learn how to use one trick in one scenario, understand it fully, and then we move on to the next one. That way I'm not bombarding you with 100 different tips and tricks before you even get to see what a question could look like. So without further ado, let's get started. So for the first example, I'm going to take a fairly short example. It's just going to be to prove that n squared minus n is even. And this is for all values of n, all integers, okay? So all we need to do here is, well, what can we do with this statement here? Well, the first thing I can see is that we can factorize. So let's try factorizing, see if that helps us out. Okay, so we have n and then n minus 1. So what are these two numbers? What's the relationship? Well, this is one number and this is a different number. Okay? If you remember in algebra, n always has to be the same number when you have a certain expression. So this value of n here and this value of n are the same value. So it could be, for example, n is 4 or 5 or 6 or whatever. So what this is it's two consecutive numbers multiplied together. So it's two consecutive. So consecutive just means they're next to each other on a number line. Integers just means they're whole numbers multiplied together. So it's two consecutive integers multiplied together. With proofs, you always have to write a sentence or two to draw a conclusion. You can't just do it with maths. You can have your entire proof by maths, but then you have to write a conclusion. And if you notice, two consecutive integers, that's going to be an even and an odd number. Okay? So this is an even multiplied by an odd number. Okay? And that's really special, because an even times an odd number is always even. Okay? The reason for that is that even numbers are always divisible by 2, which means you're essentially timesing the odd number by a factor of 2 or a multiple of 2, which means it has to be even. So for example, 2 times 1 is 2. Then you could also have 3 times 2, which is 6. Also, it could be the other way, right? The consecutive integers. So it could also, it's the bigger number times the smaller. So it could also be 5 times 4. That also fits this description, right? Which is 20. So it's always even. So here would be a proof by deduction. Okay? For the next example, let's take something slightly more interesting. We're going to say, or we're going to try and prove that the square of an even number is also even. So this might seem fairly self-explanatory to you, right? If you square any number that's divisible by 2, then the result is also divisible by 2. But you need to be able to show it mathematically. So an even number, as I said earlier, even number, you can always write it as 2 times an integer. So where n is an integer. Okay, so now it's saying to take the square of the even number. So let's do that. Let's do 2n squared. Well, that would give me 4n squared. 2 times 2 is 4. N times n is n squared. Okay, so is this divisible by 2? So even numbers are divisible by 2. So I can factorize out a 2. So hence, the result is divisible by 2. Therefore, is even. So these 3 dots in like a triangle formation always mean therefore. You'll see it a lot in proofs. Okay? So hopefully this logic makes sense to you. Even numbers are always written, or can be written, as 2 times an integer, where n, in this case I used n as the integer. It then said prove that the square of the even number is also even. So I squared 2n, which gave me 4n squared. Now, if something is even, it is divisible by 2. So what I did is I factorized out a 2 to show it can be divided by 2. In proofs, if you can factorize by a number, it means that that value is a multiple of that number. So let's say if I can factorize out a 3, it's a multiple of 3. If I can factorize out a 4, it's a multiple of 4. Now, the last question or example I want to go through is actually an A-level maths question from the Edexcel exam board, and it's May 2020, paper 1, question 13. Now, if you're not doing Edexcel or you're not doing A-level maths, that's totally fine. I just thought that this was a pretty good question that would be useful for you to know. So regardless of what kind of proofs you're doing or what level you're doing it at, this is a really good question, okay? And the reason for that is, I'll show you. So 4a over b plus b over a is greater than or equal to 4. And it says that prove for all positive values of a and b that this is true. So I'm going to write out the expression one more time. Now the reason why I chose this question is because it's very difficult to know where to start, right? Now it says for all positive values of a and b. Well, I can't just sub in every value of a and b because there's an infinite number of those numbers and that'll take a very long time. But I also can't really show it algebraically yet. So what I'm going to do is just do whatever I can do. Okay? So generally speaking, when we have two algebraic fractions, or two fractions in general, we want to combine the fractions. Now to combine fractions, we need to make sure their denominators are the same. So we need to times this one top and bottom by a, and this one top and bottom by b. So let's see what that gives us. Well, that gives me 4a squared over ab plus b squared over ab is greater than or equal to 4. Now I can combine the fractions just by adding fractions. So again, as long as the denominators are the same, I can add these together. So 4a squared plus b squared over ab greater than or equal to 4. Okay, so I can make this into a quadratic expression. So there's nothing else I could do here. So what if I just get rid of the fraction, because everyone hates fractions, they're disgusting. So times both sides by ab, we get 4a squared plus b squared. Timesing the fraction means that this part cancels out. So we have greater than or equal to 4ab. Okay, and let's draw a straight line down there. And I can make this into a quadratic by subtracting 4ab from both sides, which would get rid of this on the right hand side and get rid of this. So that gives me 4a squared minus 4ab plus b squared greater than or equal to 0. Okay, now I can factorize this, and the way we can see if we can factorize is if we look at the first and last values. Let's see what we can do. Well, if I wanted to factorize 4a squared, I'd want the first value in my bracket to be 2a. And that would be 2a times 2a. So my other bracket is also going to have a 2a in it. Okay. Then if I look at the end, we have a b squared. And it's a positive b squared. So I either have plus b in both brackets, or I have minus b in both brackets. Okay. Now if I look at this thing in the middle, it's negative, which means it must be minus b. And that's so the cross terms can multiply out to give me minus 4ab. Now, since these two brackets are exactly the same, I can just write this as 2a minus b all squared is greater than or equal to 0. And if you expanded this out, you'd find that it gives me the exact same thing. 2a times 2a is 4a squared. Minus b times minus b is b squared. 2a times minus b gives me minus 2ab, and then do the same thing again, gives me minus 4ab. Now let's look at this expression here. All of these values are positive. Okay? So all values positive, so a and b are positive. And in terms of this bracket, anything squared so if 2a minus b is 0, 0 squared is also 0. Good. If 2a minus b is positive, a positive number squared is also positive, so it's greater than 0. Good. If it's negative, a negative number squared is positive, which is greater than 0. Okay, so anything squared is always greater than or equal to 0, which means this is completely true. Okay? So in terms of the prove by counter example, that's going to be in a later video, but you're more than welcome to try it out now. It will come back later on though. So that covers the overall method for proof by deduction. So normally you're just going to be manipulating algebra and using simple facts to try and draw conclusions from other expressions. So as I mentioned earlier, I will be introducing more and more of those tricks as we go through all of these proofs in the future, and I do aim to cover a bunch of them. However, if you come across any proofs that you would like me to go through, please leave a comment on this video, and I hope that you have a truly wonderful day.